This is section 10.5. We're going to apply other relationships in circles. We're going to look at one theorem in this video. We know that the measure of an inscribed angle is half the measure of its intercepted arc. This is true even if one side of the angle is tangent to the circle. So what they're telling you there is this chord and this tangent ray also make an inscribed angle. Notice how the vertex of this inscribed angle is on the circle. That's what an inscribed angle is. So even if it's made with a tangent and a chord, it's still considered an inscribed angle. Theorem 10.11 tells you that if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is half the measure of its intercepted arc. So this green arc is the intercepted arc for that inscribed angle. We'll just keep this simple and we'll say that this angle, or that intercepted arc rather, is 100 degrees. What would the measure of the inscribed angle be? It would be half of it, 50 degrees. Okay, now pay special attention here that this angle, part of it is on the circle and part of it isn't. It's this entire blue angle that I'm highlighting right now that's 50 degrees. Okay? Now the nice thing about this theorem is on the other side, you also have an arc. So you have this green arc and this blue arc that make the circle. So if the green arc had a measure of 100 degrees, this blue arc has to have a measure of 260. And then you could use theorem 10.11 again to find the measure of this highlighted yellow angle. Notice how it's made with a chord and another tangent ray. That's also an inscribed angle. That guy would be half of that 260. So it's 130. Notice how the 130 and the 50 add up to 180. That should not be a surprise to you because that's a tangent line. So those two angles are going to be supplementary. Okay, so in these next two slides, we're just going to work through some examples using that theorem. So we're going to find an angle and arc measures. Line M in both diagrams is tangent to the circle. So they're telling you that. You didn't need to figure it out. Find the measure of the indicated arc or angle. So in this first example, we're looking for the measure of angle 1. That's that red inscribed angle. This black intercepted arc is 130 degrees. So that red angle is going to be half of that. So we'll call it 65. In the second one, we're finding the measure of arc KJL. Now make sure you know where that is. Remember, arcs named with 3 letters are major arcs. So we're referring to that one, starting at K, going through J, and stopping at L. They're telling you that this inscribed angle, it's made with a chord and a tangent ray, is 125 degrees. What would the measure of that blue intercepted arc be? It'll be 250. It's going to be twice as big. Okay, now remember, in both of these examples, you can actually find the other arc and the other angle measure as well. Here's some guided practice. We're going to find the indicated angle measure. So we're using that theorem 10.11 again. The measure of our intercepted arc is 210. So the inscribed angle would be half of that. It would just be 105. So that red angle right there is 105. In this middle example, they want you to find the measure of arc RST. That would be this guy. Can you find the measure of that arc if the inscribed angle was 98? Yeah, it's just twice as big. So it would be 196. Last one, we want to find the measure of arc XY. Notice how that's 2 letters. So arc XY could be that bluish arc, or could it be this magenta arc? Well, let's pretend it's the blue one for a second that we want to find. The blue inscribed angle is 80 degrees. Wouldn't that make the blue arc 160? So that means the magenta arc has to be 200, because 160 and 200 make 360. 2 letters when you name an arc means it's a minor arc. So do we want the 160 or the 200? You want that 160. Remember, the major arcs are bigger than 180. So if you were to name that magenta arc, you'd have to use 3 letters.